Okay, so let's jump right in. If you work in high-end video, I'm talking 4K broadcast, huge live sports, that kind of thing, you know the real headache is distance.
hmm
How do you get a perfect 12G SDI signal, which is just moving a massive amount of data from one end of a stadium to the other, or even further?
Right, and that's what we're digging into today. We're looking at a specific solution, the DVIgear DVI-7346. It's a 12G SDI fiber optic extender.
So this isn't just about making a cable longer. This is, some serious engineering.
It really is.
Right.
Its whole job is to take that electrical SDI signal, turn it into pulses of light, and then just shoot it down a single tiny strand of fiber optic cable.
And then it converts it back on the other side perfectly.
Exactly. It's the bridge that makes these long-distance, high-res productions even possible.
And the numbers here, they're pretty staggering. We're talking about full support for 12G SDI.
Which means it handles data rates up to, 11.88 gigabits per second? Just a fire hose of data?
And it does that over a standard distance of up to 6.2 miles. That's about 10 kilometers.
Yeah, that's already impressive. But here's the kicker. They have an extended length option.
Oh, really?
Yeah, and that pushes a stable signal up to 25 miles, almost 40 kilometers.
25 miles,
Yeah.
that's not just a big venue. That's linking buildings across a city.
For sure. And that's what separates professional gear like this from, anything you'd find for consumer use.
Okay, so let's get into the architecture. How does it actually do that? The kit comes with two little boxes, a transmitter and a receiver, a TX and an RX.
Right. And inside that transmitter, the TX, it uses something called a DFB laser.
And that's important because...
Well, a DFB, or distributed feedback laser, is incredibly stable. It creates a very pure, narrow beam of light.
So less signal degradation over that long distance.
Exactly. You can't use a cheap laser for this. The signal would just turn to mush. On the other end, the receiver has an incredibly sensitive photodiode to pick up that faint signal.
It sounds like it's also built like a tank. You see these rugged metal cases, locking connectors. If the fiber itself is so tough, why all the focus on the physical build?
Because the weakest link is always where you plug things in. Yeah. Those locking BNC connectors for the SDI cable and the locking ST fiber ports, they stop a technician from accidentally yanking a cable in the middle of a live broadcast.
That makes sense. It's all about preventing failure in the field.
Yeah, and speaking of the field, the temperature range is just wild.
I saw that. It's minus 40 degrees Fahrenheit.
All the way up to 185 degrees Fahrenheit.
That's not a studio. That's military-grade stuff. You could mount this on a vehicle in the desert or in the Arctic.
Absolutely.
Yeah.
And that resilience ties right back to why you use fiber in the first place.
Yeah.
It is completely immune to electrical interference.
Right, the whole RFIME problem.
Mm-hmm. If you've got massive power cables for stage lighting running everywhere, a copper cable is going to pick up that noise.
Huh.
Fiber just doesn't care. The signal is light, so it's totally isolated.
Okay, so the signal path is incredibly robust. But what's actually in that signal? It's not just video, right?
No, and this is where it gets really interesting. The audio capacity is huge.
How huge are we talking?
With a 12G SDI signal, this little device can carry up to 64 channels of embedded, uncompressed 24-bit audio.
64 channels. Why on earth would you need that many?
Think about an international sports broadcast. You need different language commentary tracks, you need surround sound mixes, talkback channels for the camera operators, sync cues.
Ah, okay. It all adds up, and it's all riding along with that one single 4K video feed.
All on one tiny fiber cable.
And they packed all of this into a box that weighs, what, an ounce and a half?
Yeah, 1.5 ounces. And the power draw is tiny. It's 1 watt per unit.
Which means you can power it with a normal AC adapter or even just a USB port. That's incredibly flexible.
Right. So if you kind of tie this all together, what you have here is the key piece of infrastructure for modern UHD production.
It's the thing that lets you actually use 12G SDI in the real world outside of a small studio.
Exactly. You get the bandwidth, you get insane distance, and you get resilience in conditions that would just destroy consumer-level electronics.
So for you, this really means that high-resolution, high-channel count video isn't chained to a server rack anymore. It can go just about anywhere.
It really can. And that actually raises a final interesting question for you to think about. We've talked about stadiums and broadcast trucks, but given that specific physical toughness, especially that minus 40-degree operational temperature, think about where else this could go. What kind of non-broadcast application, say in aerospace or remote scientific research in the Arctic, suddenly become possible when your critical video link is built to that specific standard of durability?